Chapter 6 is about geometry. So we will learn some properties of some standard shapes, and we will learn how to use that in finding areas, perimeters, and some other properties of figures. So basic geometric concepts and figures. We start with properties of angles. Two rays with a common endpoint make up an angle. For example, here, this ray and this ray, they make up this angle. The common endpoint, this point here, this is called vertex. This is the vertex, and this is the vertex. There are four common types of angles. Acute angle is an angle between 0 degrees and 90 degrees. So this one is acute angle. Right angle is 90 degrees. Obtuse angle is larger than 90. And straight angle is 180 degrees. And this little circle here is red degrees. Now, we have what's called supplementary and complementary angles. Two acute angles are complementary if their sum equals 90. So if we have two angles like this and the sum of them is 90 degrees, then we call them complementary. They complete each other to 90. In other words, if we have the angle A and angle B between 0 and 90, then they are complementary if their sum is 90 degrees. For example, we may have the angle 30. What is the complementary of this? We need to complete this to 90. So the complementary will be this angle from the x-axis or this coordinate, or this ray to this ray. So this is 60, so 60 plus 30 is 90. So 60 degrees, the angle of 60 degrees plus the angle that has measure 30 degrees give us 90 degrees. So the complementary of 30 degrees, the angle of 30 degrees measure, is the angle of 60 degrees measure. Now let's talk more about the angles, how they form. We have what's called initial side, and we have terminal side. And we have a vertex here. They meet at the vertex, and this is the angle. Now we measure the angle to find its measure. Now two angles are supplementary if their sum is equal to 180. For example, we may have 120 degrees and 60 degrees. They are supplementary because their sum is 180 degrees. Now, if we want to find the angle DBC, this angle here, these two angles form straight angle. Straight angle means 180 degrees. So we have 136. What is the complement of, or what is the supplement angle? Because supplementary means their sum is 180. So 180 minus 136 degrees is 44 degrees. So this angle has measured 44 degrees. Now look at the angle here, RST. RST, this is right angle, has measured 90. We want to find the measure of the angle. This is usually used to denote angle, either this or this for angle. Okay, so PST, I mean this angle. What is the measure of this angle? If we know that this is 67, these are complementary angles. So 67 degrees plus what equals 180. This is 132. Sorry, 90. Is sum up to 90. So this is 23 degrees. So this is 67. In order to complete it to 90, we need 32 degrees. So this angle 23 degrees. Now if we find the sum, 23 plus 67 is 90. Now we have a figure, basic figure that's called triangle. Triangle is a geometric shape made of exactly 3 angles and 3 sides. So tri is used to denote, to mean 3, this prefix, and the root word is angle. The angles that make the triangle are called vertices of the triangle. So for example, this is triangle. It has 3 angles, this, and this. 3 sides, this side, this side, this side. And these are called edges or sides. So we have angles and sides. 3 angles, 3 sides, that's triangle. Now we have 3 common types of triangles. Scalene is triangle with all sides different lengths. For example, this one, scalene, this is different than this in length. We have equilateral that has all sides are equal. For example, this one is equilateral. All sides are equal. We use this dash to denote equal sides. This is equal to this, equal to this. And we have isosceles. Isosceles triangles are triangles with 2 sides. Only 2 sides are equal. This one and this one. As you can see, we have same symbol here, or we have dash here and same thing here. This means they have the same length. Now, types of triangles given by their angles. This is called acute triangle because all angles are acute angles, less than 90. This is called obtuse triangle because it has one angle that's larger than 90. This one is called right angle triangle because it has one angle that's equal to 90 degrees. The sum of angles, interior angles of a triangle is 180. So if we find the sum of this, this, and this, it will give me 180. Now, we can find the length of sides or angles by using some techniques and by paying attention to this rule. Sum of the angles of a triangle is, interior angles of triangle is 180. Here we have an example. A triangle has 2 angles that measure 35 and 75. So let's see, this angle has, this is 35 degrees. Let's say this is not accurate graph, but maybe this is better graph. If this is 75 degrees and this is 35 degrees, find the angle of the measure of the third angle. Now we know that the sum of the angles is 180, right? So 35 degrees plus 75 degrees plus the third angle should equal to 180. So the sum of those is 110 plus what equals 180. So this angle has measure 70. So the missing angle's measure is 70. Now, one of the triangle in a one of the angles in a right angle triangle measures 57 degrees. Find the measure of the third angle. It's right angle triangle. So this angle is 90 degrees, and one of them is 57. Let's say this is 57. We know that the sum should be, this should sum up to 180. So 90 degrees plus 57 degrees plus this angle should equal to 180. So the sum of those, 147 plus what equals 180. Now this angle has measure. So what is the quantity, or what is the number that if it's added to 147 gives 180? 33 degrees. Now we have what's called Pythagorean theorem. This is a very important theorem in geometry. It says that if we have right angle triangle, this is right angle triangle, then the sum of the squares of the lengths of the legs, this leg and this leg, if we square A and square B and find the sum, this will be equal to the sum of the square of the hypotenuse square, or this will equal to the square of the length of the hypotenuse. So A squared plus B squared equals the hypotenuse squared. This is a very important, powerful rule. It will help us to find the lengths of sides for right angle triangles. So it's only work for right angle triangles. Find the missing side by using the Pythagorean theorem. So if we know that this is 4, this is 3, we want to find C. So Pythagorean theorem says that the hypotenuse squared is equal to the squares of the sums of the two legs, or the sum of the squares of the legs. So C squared equals 16 plus 9. C squared equals 25. Now what is the angle whose square is 25? The angle is 5. Or you can take the square root of 25. Another example, if this leg has length 12 and the hypotenuse is known to be 13, what is the size of the third or the second leg? We have 13 squared equals the hypotenuse squared equals 12 squared plus B squared. We don't know the value of B, we want to find it. Now this is 169, we can use the calculator. 13 squared, and 12 squared is 144 plus B squared. Now B squared is 169 minus 144. So what is 169 minus 144? It's 25. So what is B? B is 5. If we square 5, it will give us 25. Or what is the square root of 25? So this is 5. Now we have sailboat has a large sail in the shape of the right triangle. The longest edge of the sail measures 17 yards. This is 17 yards. And the bottom leg has measured 8 yards. How tall is the sail? What is this, the length of this side, the other leg? So we apply Pythagorean theorem. 17 squared, the hypotenuse squared, equals 8 squared plus, let's call this side B, B squared. Now 17 times 17, you can use the calculator. $289 equals 64 plus B squared. Now what is B squared? B squared is 289 minus, we subtract this from this, 64. And that is 2 225. So b squared is 225. Now we find square root of 225. What is the square root of 225? It's 15. So b is 15. So that's the how tall is the sail? It's 15 yards. Okay. Now another concept, we have similar angles. We say that we have two triangles that are congruent if they are exactly the same size and shape. They are exactly the same. If the congruent triangles, the measure of the corresponding angles and the corresponding size is equal. But sometimes we have similar angles. If the corresponding angles of two triangles have the same measure, they are similar. And even if the sides are not equal. So similar triangles have the same shape, but not necessarily the same size. When a pair of triangles is similar, the corresponding sides proportional to one another. For example, those two triangles, if we just look at them, they look the same or similar, but they are not exactly the same. They look similar, but not exactly the same. So we sometimes use this notation, that we use this to say that they are similar. Now we have same corresponding angles. We have right angle here, this, same measure, but different size. This is smaller than this, but there's some proportion, some ratio. For example, if we divide 42, this side, by the corresponding one, 35, this should be equal to this side divided by the corresponding one. And now we can solve for x to find the missing angle or the missing side length. So how to solve this? We can multiply this way and this way. So we have 42 times x equals 66 times 35. Now we have 42 equals, now what is 66 times 35? 66 times 35 is 2,310. And then to solve this, we divide by 42, the coefficient of x. So x is equal to now we use the calculator to divide 2,310 by 42. That's 55. So we know that this is 55. So we use the similar triangles to find the missing side length by finding corresponding ratios. Here we want to determine the y, the length y, if we know that they are similar triangles. So we divide 42 by 63 or vice versa. So we can say 63 divided by 42 or 42 divided by 63. We also can divide y by 42 and 15 by 63. They should be equal. So either one divided by the corresponding one or two sides and the corresponding sides, they should be equal. So here y over, for example, let's use this idea. We can divide y by 42 equals 15 divided by the corresponding ones. The corresponding one for y is 15. The corresponding y for 42 is 63. This is one way to do the problem. And then we solve for y. Or we can divide the corresponding sides. This by 15. Y over 15 equals 42 divided by the corresponding side, 36. You can use either way is fine. Let's use the second way to do this, maybe because we used it in the first problem. Let's use it again. So y over the corresponding side length, 15, and 42 divided by 63. Now we cross multiply these. Y times 63 is 63y equals 42 times 15. Now what is 42 times 15? This is 630. And then we solve for y. That means we need to divide both sides by the coefficient of y. Y equals 10. If we divide 630 by 63, this will give us 10. So this side has length 10 meters.